Okay, after learning the basic concepts of net section and net section failure, we are all set to study about block shear. Block shear is actually the tearing out of a block from a tension member. Okay, for example, it is actually a special type of net section failure. What happens, for example, if we have a tension member and it is any channel or an angle, and this is a gusset plate, and they both have been connected using bolts, 4 bolts. So whenever a force P or tensile force P is applied here, uh, the part of gusset plate that is along this P, I mean these two parts, that would experience shear because they are along P, and part of this gusset plate that is perpendicular or normal to this P will experience tensile forces. As a result, a block will be teared out of this connection or pulled out from this connection. Okay, this is a very common phenomenon, and it commonly occurs in tension member. For example, this is a tension member and we have P as a tensile force. We can see that we have two paths in shear and we have one path in tension. So I mean it's a combination of tensile and shear failure. Okay, this is the formula for nominal block shear strength. We can measure the nominal block shear strength using this formula. This formula is very informative. Fu is actually the ultimate stress of steel. For A36 it is 58 ksi. Fy is actually yield stress of steel, and for A36 it is 36 ksi. And 0.6, it is actually the ratio between Fy and Fu. If you divide 36 by 58, you will get 0.6. Okay, there are some other very important terms here. For example, this A and V. A and V is actually the net area in shear, or actually we can call it shear fracture or area involved in shear fracture or shear rupture, because this is shear and N is net area, and we know that net areas are involved in rupture or fracture. So I can call it a shear fracture or shear rupture, area involved in shear rupture or shear fracture. Similarly, I have net area in tension, A and T here. And I can also call it area involved in tensile fracture or tensile rupture, because this is tension and net area. N represents net area and net area is involved in rupture. Finally, I have AGV. It is actually gross area in shear, or it can be termed as area involved in shear yielding, because V is shear and you know gross area always undergoes yielding. Okay, then UBS. It is actually, it depends upon uniformity of stresses. It would be explained in future lectures inshallah, but we can use two values, a 0.5 or 1, and it would be given actually in the numerical. Okay, we have a problem. The problem is that we have a tension member and it is A36 steel, and we know Fy is 36 ksi and Fu is 58 ksi. The load on the structure is 225 kips according to LRFD, and similarly load on the structure according to AST is 150 kips. The thickness of the plate is given, the dia of the bolt is given 7 by 8 inches. So we have to find its block shear strength. In order to resist the block shear in this tension member, our block shear strength should be greater than these two values. If we are using LRFD, it should be greater than 225 kips, and if we are using ASD, then our block shear strength should be greater than 150 kips. And you can see the direction of force, tensile force that is being applied, and as a result this block would be teared out. Okay, I have to calculate everything represented in that formula, that is AGV, A and V, A and T. So one by one I'll be calculating each and every term. For example, I have to calculate AGV. So going back to last slide, for example here, and I have to calculate AGV. We know these two paths along T are in shear. So actually there are two paths. So I'll multiply 2. Okay. and I have to multiply the length or this width. For example, 3 plus 3 plus 3 plus 2, it gives me 11, and I have to multiply it with the thickness of this plate, and that is 0.5. As a result, I get 11 square inches. Okay, next I have to calculate the net section in shear. This is very important. This is very important, and net section has to be calculated very carefully. We know, for example, this 11. 11 is what? 11 is WG. WG. Okay, minus NDT. This is N. It means 3.5 bolts will appear along this path. Okay, 7 by 8 inches what? This is actually the die of bolt, and 1 by 8 inches allowance, and this is thickness T. So it is very simple. I have multiplied it with 2 because we have two paths along shear. 11 is the gross width and 3.5 bolts are involved. I will show you how. Okay, this, if I erase everything here, okay, two paths, I have to use 2. Okay, I have to use 2. Then I have a gross width of 11. 3 plus 3 plus 3 plus 2. Okay, minus WG minus NDT or ND, simply ND, because you will multiply T here. T is 0.5. Okay, I have to use ND. So number of bolts here are actually 1, 2 and 3. And this half bolt, 2 has been multiplied for 2. Okay, this 2 has been multiplied for 2 failure path. Okay, 3.5. I have used 3.5 because this final bolt has been cut into half. For example, I can show you here. 1, 2, 3 and this half. As a result, the value of N will be 3.5 and not 4. Obviously, I have multiplied it with 2, so I'll get 7. For example, this you can see here. Okay, 1 bolt, 2 bolt, 3 bolt, 3 holes. Okay, and this half hole. As a result, I have used 3.5. Similarly, when I'll be calculating the net area in tension, you should know that this half bolt and half bolt will be used. Okay, next, finally, okay, I have calculated this 7.5 square inches. 2 has been multiplied because they are 2 failure paths. Finally, I have a net area in tension. So it should be perpendicular to that P. This should be noticed or noted down. Okay, 6 minus again 7 by 8 inches. It's actually the dia of bolt, and 1 by 8 inches is allowance, and half is the thickness of the plate, and 6 is the width along tension. Okay, see here, this is tension. This is the area that undergoes tension. So I mean the length here is 6. So I'll be using WG as 6 inches. Okay, again, very important point, number of holes. Number of holes involved in this failure, that is net area failure, are half and half, gives us 1. Going back. Okay, here half of the bolt is tiered and here half of the bolt is tiered. Half plus half gives us 1. Okay, I have used 1 here. This is 1. T. This is T. Okay, I've got net area in tension as 2.5 square inches. Okay, I'll use this formula and simply I've put the values. 0.6 into 58. A and V is actually calculated here, 7.5. And then UBS is given, that is in this formula, is in this numerical it is 1. FU is 58 and T is 2.5. You have just calculated. And you have sorted out, and you have ultimately you have obtained 406 kips and 383 kips. So you have to select the lower of these two values. So here these two values have been obtained from right hand side and left hand side, but you have to select the lowest. So this is my block shear strength. If we multiply, or I multiply it with phi or phi, the resistance factor, that would be given 0.9, we'll get 287 kips. And if we divide it by factor of safety, it will get 192 kips. In both the cases, the adequacy has been satisfied, because 287 kips is greater than 225 kips given in LRFT, and 192 kips is greater than 150 kips, and again it has been given in the formula. One thing finally, the numerical is completed now, but I want you to get a very clear concept about this part, how to calculate the gross area in shear. तो मैं उर्दू में थोड़ा सा आपको बताता हूँ अगर आपको समझ ना आए कि ग्रॉस एरिया इन शेयर में सबको यहाँ पे क्लियर करता हूँ अगेन. ओके, ग्रॉस एरिया इन जब मैं शेयर कैलकुलेट करना चाहता हूँ तो मुझे ये बात पता होनी चाहिए कि मैंने अलॉन्ग टी कैलकुलेट करना है. तो आप देख सकते हैं कि ग्रॉस एरिया में दो पार्ट आए हैं, दो पार्ट्स हैं, तो ये दो, तो मुझे 2 से मल्टीप्लाई करना है. ठीक है, अगेन मुझे विड्थ चाहिए 3, 6, 9, 11, ओके 11, और थिकनेस मेरे पास है तो हाफ आ गया. तो ये कैलकुलेट करना बहुत आसान था, तो ये करना कोई इतना मुश्किल काम नहीं था. नेक्स्ट जब मैं ये कैलकुलेट करना चाहता हूँ, ये नेट एरिया इन शेयर ANV, ये बहुत इंपॉर्टेंट है. तो जब मैं ये कैलकुलेट करने जाऊँगा तो मुझे ये बात पता होनी चाहिए कि मैंने उसी डायरेक्शन में, टी की डायरेक्शन में रहना है. और आपको पता है 2 पाथ है, तो मैं 2 से तो मल्टीप्लाई करूँगा ही करूँगा. ठीक है, उसके बाद अगेन मुझे ग्रॉस विड्थ WG चाहिए 3, 6, 9, 11, ओके 11 हो गया से 11, माइनस ND, ये WG है, आपको पता है ये WG था, माइनस ND, और ये पूरा का पूरा मल्टीप्लाई हुआ है किससे, थिकनेस T से. तो T ब्रैकेट के बाहर ही है. GN की वैल्यू मुझे बतानी होगी, लेकिन उससे पहले मुझे D का पता है. D क्या है आपको पता है, डाया बोल्ट 7/8 इंचज़ है. ओके, और अलाउंस आपको पता है 1/8, आपने वो तो आसान ही आप डाल ही लेंगे. ओके, एंड T की वैल्यू भी आपको पता है 1/2 और 0.5 है. मसला यहाँ पे आता है कि N की वैल्यू क्या है. तो N की वैल्यू क्या है भाई, ये वैन की एक, ये पूरा बोल्ट, ये पूरा बोल्ट, ये पूरा, और ये हाफ, इसीलिए मुझे यहाँ पे 3.5 लिखना है. ओके, इट कैन बी सीन फ्रॉम द फिगर एज वेल, दिस फिगर एज वेल. ओके, this hole has been teared out, this one as well, but here half hole has been teared out. As a result I have used 3.5. ये बात आपको समझ आ रही चाहिए. ओके, फाइनली अगर एक और आखिरी चीज़ जो कैलकुलेट करनी थी वो नेट एरिया इन टेंशन था. बहुत आसान है. और नेट एरिया इन टेंशन कैसे कैलकुलेट करना होगा कि मुझे अब जो विड्थ चाहिए वो लॉन्ग टेंशन चाहिए, जो कि ये रीजन है 6. तो मैंने 6 में से कितना क्या माइनस करना है, वही फार्मूला मैं यही फार्मूला यूज़ करूँगा. 6 लगा दूँगा, 2 की जगह 1 आएगा क्योंकि एक ही पाथ है. ठीक है, 6, उसके बाद ND आएगा, डायाफोल, वो तो आप फाइंड कर ले, लेकिन N की वैल्यू 1 आएगी. N की वैल्यू 1 क्यों आई, देखें जी, यहाँ पे N की वैल्यू 1 है. दिस इज़ N, दिस इज़ N, दिस इज़ T, एंड दिस इज़ T. N की वैल्यू 1 इसीलिए है. मुझे दोबारा जाना पड़ा. N की वैल्यू 1 किस लिए भाई, अभी आ जाएगा. N की वैल्यू 1 बिकॉज हाफ बोल्ट ये है और हाफ होल ये. हाफ होल गिव्स यू 1 होल. तो हम यहाँ पे भी देख सकते हैं. अगेन ये मुझसे यहाँ पे जा रहा है, क्या हो गया इसको. आपको समझ आना चाहिए. ये देखिएगा टेंशन के अंदर, देखिएगा जी, देखिए हाफ, इस टेंसाइल रीजन के अंदर भी, इस वर्टिकल टेंसाइल रीजन में भी आप देख सकते हैं कि हाफ बोल्ट अभी भी इंटैक्ट है और हाफ बोल्ट इधर अभी भी इंटैक्ट है. इसका मतलब है कि जो एक बोल्ट हाफ अभी भी इंटैक्ट है, तो इसका मतलब है कि हाफ अभी भी हाफ में फेलियर हुआ है और हाफ इंटैक्ट है। इसका मतलब हाफ गिव्स यू 1। तो ये बड़ा आसान है, कोई इतना मसला नहीं है। और आप अल्टीमेटली ब्लॉक शेयर मालूम करते हैं और फिर आप देखते हैं कि लेफ़्ट और राइट हैंड साइड में से कौन सी लोअर वैल्यू है। आपको कंजर्वेटिव साइड पे रहना पड़ता है। यू हैव टू बी ऑन द कंजर्वेटिव साइड, सो यू विल ऑलवेज सिलेक्ट द लोएस्ट वैल्यू। सो आई हैव सिलेक्टेड 383 किप्स। फिर आप उसको LLFD और ASD के फैक्टर ऑफ सेफ्टी और रेजिस्टेंस फैक्टर अप्लाई करते हैं और फिर उसको कंपेयर करते हैं कि आपको जो स्ट्रेंथ गिवन है ये उससे ज़्यादा है या कम है। ये बहुत प्रिलिमिनरी और बहुत सिंपल लेक्चर था और इंशाल्लाह आपको समझ आएगा। आगे थोड़े न्यूमेरिकल इसमें कॉम्प्लेक्स या कॉम्प्लिकेटेड आ सकते हैं, लेकिन वो भी इंशाल्लाह आसान होंगे। तो कोशिश करें इसको पढ़ें, बुक से भी पढ़ें, सेगवाई की बुक है और बाकी बुक्स भी कोई अगर आपके पास हैं तो इंशाल्लाह आप उससे पढ़ेंगे तो आपको समझ आएगा। थैंक यू वेरी मच।